Welcome back, Physical Science 20. This is the second part of the 6.4 booklet looking at molar masses, and with the second part we're going to look at calculations involving molar masses. So to do that, we're going to look at converting mass to amount, and of course in this booklet amount refers to moles. So we're going from grams to moles. So if you look at your little chart here, when going from grams or masses in grams to moles, take a look here, we're gonna multiply by the factor of 1 mole over the molar mass. So our molar mass is in units of grams per mole, so we're going to arrange it like this with the molar mass on the bottom. After that we'll be going from moles to grams. With that you're going to rearrange the grams per mole molar mass in this fashion with the grams on top, moles on the bottom. But for this first one we're going from mass to moles, so we're going to have 1 mole over the mass of what that molar mass is. So here earlier we found that sodium hydroxide is 40.00 grams per mole, so changing grams into moles, we of course are multiplying by that factor, 1 mole over the mass. So 40 grams per 1 mole, so if you recall, this can be illustrated as 40 grams over 1 mole or 1 mole over 40 grams. It all depends on what we're trying to find out. What we're trying to determine, moles, it'll always be on top. Where you're coming from, grams, that of course will go on the bottom. So cancel, cancel. 4 times 1 divided by 40, 0.100 moles of sodium hydroxide. So 1 mole over the mass, just like here, 1 mole over the mass. Okay? If we're doing the opposite, if we're converting from an amount to mass, in other words, from moles to mass, that's vice versa. Moles to mass, the grams are going to be on top, moles on the bottom, because of course what you want to cancel is moles and what you want to be left with is grams. So here we're looking at, let's see here, oh here we go, I had it hidden. How many grams is 1.50 moles of sodium hydroxide? So we're starting with moles, going to grams, starting with moles, going to grams. So this time we're going to multiply by 40 grams. And you can see here by the canceling, numerator cancels with denominator in terms of the units, and we're left with units of grams. So 1.50 multiplied by 40.0 yields 60.0 grams. Okay, and that's all there is to it. We're just simply looking at this part of your conversion chart, grams to moles, moles to grams, and you can see when you cancel, if you can cancel out the unit you're starting with, then and ending up with the unit that you're looking for, you're doing it right. Okay. And they have this schematic here, but I really like using this one more because I think it makes more sense. It's a nice visual to show you where you're starting from, where you're going to, and then the right conversion that you're going to be using for there. Okay, here's another tutorial here, or another sample problem. According to the manufacturer, a typical can of Coca-Cola contains 40 grams of sucrose, which is C12H12O11. Calculate the amount, and of course, yeah, amount means moles in this booklet, of sucrose in 40 grams. So we're going from grams to moles, grams to moles. So we're going to be using the molar mass, and we're going to be dividing by the grams because remember we're canceling grams, and we want to end up with moles. So of course what you have to do first is figure out the molar mass of sucrose. So 12 carbons, 22 hydrogens, and 11 oxygens. When you multiply that and add that all up, 342.34 grams per mole. So of course you have two factors with that molar mass. 342.34 grams over 1 mole, or 1 mole over 342.34 grams. So that's our molar mass conversion. But since we're going from grams to moles, we want grams on the bottom, moles on top. Grams on the bottom, moles on top. So that's the conversion factor we'll be using. So as you can see here, 40 grams multiplied by 1 mole over 342.34 grams. Grams cancel, 0.117 moles. 3 sig figs because my original number had 3 sig figs. Okay. Another example here. Here they're talking about looking at changing from millimoles to mass. And millimoles, there's 1,000 millimoles in 1 mole, so quite easily you just divide it by 1,000 there to change it into moles. Okay. Finding the molar mass of glucose C6H12O6, 180.18 grams per mole. This time we're going from moles into grams, moles to grams. This time multiplied by grams divided by moles, which makes sense because we want to cancel the unit of moles and end up with grams. 0.72 grams. 2 sig figs because 4.0 is 2 sig figs. Okay. There's some practice questions over here as well. I worked through some answers here. I think I did the first one in each of these. So just more practice. And again, wherever they use the word amount, that means moles. Calculate the amount or moles of pure substance in each of the following, and then here vice versa. Calculate the mass when given these amounts. So here 5.00 times 10 to the 2, or 500. Of course, to show that there's 3 sig figs, we write in scientific notation, because just simply running 500 only implies 1 sig fig. So calculate the number of moles in 500 grams of table salt, i.e. sodium chloride. So grams to moles, grams to moles. We're going to figure out the molar mass, and we're dividing by the number of grams in 1 mole. Okay, so if I go to the next page there, you have to figure out the molar mass of sodium chloride first. Sodium chloride, of course, is 1 sodium and 1 chloride. So 22.99 plus 35.45, and I get 54.44 grams per mole. We're going from grams to moles, so we want grams on the bottom, moles on top. So we would arrange that molar mass like this, just like back here, grams to moles, 1 mole over the mass, 1 mole over the mass. So 500 times 1 divided by 58.44, 8.56 grams of sodium chloride. And of course 3 sig figs, because I have 3 sig figs over here. Okay? And then if you want to run through these, you can, because it's nice because the answers are right here, so you can see if you're on the right track. Maybe do at least one just to make sure you got it before doing the assignment. 2A, find the mass if we have 0.80 moles of hydrogen peroxide in a bottle of antiseptic. So if we take a look here, we're going to be going from moles to grams. Moles to grams requires multiplying by the molar mass, the grams on top, moles on the bottom, because you want to cancel the moles. So of course we have to figure out the molar mass of hydrogen peroxide. So H2O2, 2 hydrogens, 2 oxygens, 2 times 1.01, 2 times 16.00, so we get 34.02 grams per 1 mole. And of course we want to go from moles to grams, so moles will be on the bottom, grams on top. So our 34.02 grams for every 1 mole will be arranged like this. 0.8 times 34.02 grams divided by 1, 27 grams. And of course 2 sig figs, because we have 2 sig figs there. Okay, and again you can maybe do one more here just to make sure you have it, and the final answers are there. Okay, so summary here, the molar mass and average atomic mass are numerically the same, but of course they have different values. Atomic mass is atomic mass units, relative masses to each other, whereas molar mass, we're looking at the mass of 1 mole of substance, or 6.02 times 10 to the 23rd particles, which are atoms, molecules, or formula units. The unit for mass is grams per mole, whereas the average atomic mass is little u, or AMU. The molar mass of a compound is the sum of the masses of each entity in the compound. And then doing these calculations, rather than using this formula here, simply use this little schematic here that you have a copy of, because you can see the pathway of where you're starting from and where you need to go. So the questions I would like you to do, highlight number 1, number 4, all of them, 5 and 6, 7, 8, and 10. And of course, I just kind of indicated here, wherever the word amount appears, that really means moles. Okay? So there you have it. So just those questions for 6.4 and molar masses and the two calculations involving grams to mole and moles to gram. See you again.